Right now, this wall of steel is the only thing stopping millions of tons of water from crushing me. And if this wall fails, there will be no escape from here. I'm standing inside an area engineers intentionally designed to perform repair and maintenance on this massive gate. While millions of tons of reservoir water press against a steel wall just meters away. And stick around until the end because you will see why after installing these stop logs, engineers must open the radial gate just slightly to drain this area and thus preventing dangerous vacuum from forming. And during removal, the crane operator lifts only 10 millimeter first and then waits to fill this area before removal of stop logs. Later in the video, I will be explaining the consequences of vacuum pressure. These joint steel barriers are called stop logs. As you saw in my previous video, they are installed in front of spillway gate whenever the maintenance is required. So this is a picture I took during commissioning of the stop log just to give you an idea how they move and sit in the slot. At first place, the process looks very simple. Lower the steel sections, drain the area, do the repair, but in reality, there are invisible forces that are constantly trying to destroy everything. And by invisible forces, I mean vacuum pressure, unequal water pressure, and hydraulic forces powerful enough to crush these massive steel sections like a soda can, or even damage the radial gate. And if the process is not performed carefully, let me show you why. These massive stop lock sections, each weighing nearly 60 tons, are lowered one by one into narrow slot upstream of the gate. Once they are stacked, their rubber seals create a watertight barrier, and interestingly, the pressure of the reservoir actually helps compress the seal tighter against the steel. But now comes the dangerous part, removing the water trapped between the stop locks and the gate. Because if engineers simply open the gate and drain the area too quickly, a vacuum could form inside this empty space, and that pressure difference can become incredibly powerful, strong enough to deform or damage the stop lock themselves. So to overcome this issue, a special aeration or vent pipe is connected to this chamber as I have shown in the diagram. So once the operator slightly opens the radial gate, water slowly drains out while air enters through this vent pipe to replace the empty space. This process is extremely slow and controlled. Sometime it can take almost 12 hours just to drain this area safely. Once the chamber is empty, engineers inspect the stop loss carefully for leakages. If the leakage remains within the safe limit, maintenance work can begin. But if the leakage is excessive, the entire operation may need to be stopped and the stop log removed and reinstalled from the beginning. And surprisingly, removing these stop log is even more dangerous than installing them. Because after maintenance, the chamber behind the stop block is empty, while the reservoir outside is still applying enormous pressure. And if the crane operator tried to pull the stop blocks out immediately, the pressure difference could create massive resistance. And if the stop block suddenly release somehow, millions of tons of water is going to violently rush into the empty chamber and slam against the radial gate. This sudden impact can create an effect similar to water hammer, capable of damaging the gate or even parts of the concrete structure. That is why operators first lift the stop logs only by about 10 millimeters and then wait. Because during this tiny lift of 10 millimeter, a built-in bypass valve open first. This allows water to slowly refill the chamber. I found a video of this bypass valve in action, which I took during the commissioning of these stop logs.
来，停会儿，停会儿，停会儿。
Okay. Okay. So when this valve will open, this chamber will start to fill and the trapped air escaped upward through these aeration pipes. So I've personally been involved in the operation during my career, in this operation during my career, and although I have lost the original video, I still remember watching the vent pipe during filling. The suction and airflow were enormous as compressed air mixed with the escaping water. The temperature dropped so much that the discharge become ice cold. In some cases, it can even create a snow-like mist around the outlet. Once the chamber is completely refilled with water and pressure become balanced on both sides, the stop logs can be lifted safely one by one. In the end, I want to tell you that I've spent years working around structure like this, and no one, and on this channel, I will show you the engineering most people never witness. So subscribe to Hydrovision.
से अंदर बीच में हमारा फर्स्ट नहीं कल एक फंस गया यहाँ पे आ गया ये रोप से उठाया था ना ये साइड थोड़ी लंबी थी यहाँ पे आके अड़ गया वो बड़ी मुश्किल से उसको पास करवाया। आप लोग इसके बाद तो